Hey everybody, welcome to Houdini Hangout. It is the first week of September, and we're here doing another regular Wednesday stream. So that should be pretty fun. We had an extra stream this week, and we'll have some extra streams kind of going along. Hello, Zig. Hey, Zach. How's it going? Wow, Zig and Zach. We have some extra streaming that's going to be happening, at least for some of this month and maybe a little into next, where we're going to be talking about mops every Monday. That's my brother. That would be amazing if it actually was your brother, Zig and Zach. That's funny. So hopefully y'all were able to, I said y'all. Hopefully you all were able to check out the stream on Monday, or maybe some of you did, and hopefully it was helpful and interesting. And we're gonna keep diving into mops throughout the month, and we'll kind of see where that takes us. But for tonight, we're gonna kind of go back to some more, I'm gonna say more standard Houdini fare. But yeah, it should be interesting, and should be something kind of cool to take a look at. One thing I just want to say before I get any further is, I put it in the chat, but if you want to go to the Discord server and grab the HIP file for tonight, there is a channel where I have a link to all of the HIP files. What did I call it? HIP files. Houdini Hangout HIP files. And so you can go there and find them. That's awesome, Zig. That's really cool. Zig recently graduated and used one of my lessons that's awesome. Very cool. What kind of stuff did you do for your final project? Very cool. I'll give him a second to respond. Yeah, congrats, man. Very cool. So if you go to the Discord server and go there and check out today's date, 9/6, you'll be able to, hey KG, how's it going, man? You'll be able to download the this Heightfield example, and you can kind of work through it with me as I kind of explain the different aspects of what kind of how to set this up. Let's see. Zig said, I made a Japanese inspired mountain scene. Oh, implemented a waterfall video. Cool. Awesome. Very cool. That's awesome. Well, congrats on graduating. And hopefully you're getting your name out there and, banging down some doors. I know it's a little tricky right now because of the, the strikes and things like that, but we're all kind of hopeful that things are going to clear up with that. Hey, Epoxia, welcome to the stream. Thanks for hanging out. So tonight we're going to be talking about Heightfields. I guess what I should do is bring up kind of where we kind of started here as far as the ideas and things like that kind of led us here. And we'll look at, yeah, Zig, you'll get there, man. It's always, can always be a little tricky. So, you're doing great, I'm sure. So, all right, let's see here. Oh, cool. Your trick on the burning cloth tutorial to try to create lichen generator. Nice. Very cool. It's definitely really fun to get to see other people using the different techniques and tools and things like that. Just ideas I'm kind of throwing out there and seeing what sticks, but it's awesome. Really glad. All right, so let's take a look at this. So the suggestion that I got over on the Discord server was experimenting with Heightfields. So Danny G suggested some Heightfields, some abstract kind of Heightfield effects, and there's some cool stuff here. There's definitely some really unique stuff from XK Studio. This I didn't really get into too much, but this is pretty neat as well, using Pyro and Heightfields, things like that. So that's pretty neat as well. But the thing that really kind of, grabbed my attention was this Heightfields in motion, partially because it's from a Hive and that's kind of fun, but also it's from Man vs. Machine and they're awesome. Oh, also I loaded this up and I was like, I just loaded it on my screen and I was like, saw this little red thing. I'm like, live. Oh, that's me. That's funny. It's very weird. The algorithm hard at work. So, oh gosh, I can't think of his name. Who was this? Tim Boland was doing this presentation, and here he is right there. So he's been doing a lot of stuff. He's kind of worked in the industry for a long time, and he started talking about some of these different like Heightfield examples and things like that, and looking at some different design type things and just stylistically what could be done. He also showed these things being applied to geometry. Right. So that's kind of interesting as well. I didn't really get to that point in my example that I kind of cooked up the other day because I had to actually go through this and see, what exactly it was that he was explaining and doing. So yeah, he did a bunch of different stuff in here that he kind of showed. I guess these are all using Heightfields. This one's a little different, but it's cool. Cool stuff. This sort of gave me some inspiration for like where we were going tonight with this. And obviously, shading, rendering, all that kind of stuff is a big part of this. But what he ended up showing was this. Let's see here if I can get this to play back properly. Let's see here. Where does this go? Is this playing? It is playing. So this was sort of what he was showing, more or less, where this Heightfield kind of grows in using this effect. And so we're going to talk a little bit about how that was done. And I kind of took something more like this and was kind of playing with it. Oh, play. So this is kind of cool. And this will be more or less the style of thing that we're kind of going with tonight. It's pretty straightforward to set up, actually, as that graphic, but this is the real kind of heart of the matter, is this animation right here, which looks pretty simple. However, it definitely took a little bit of time to reverse engineer. And so they go through all of these different setups here. And that's kind of what it's kind of funny because half of the talk is him talking about it. And then the other half is like basically going through this on points. And then he does like a mega speed run on doing it in volumes. And that's where all the meat of kind of the effect is, because it's slightly different. And so anyways, he gets to this stuff here. And, I was basically freeze framing and reading what he was doing and looking at it and stuff like that, just to kind of get a sense of how this was working, because he showed what he was doing, but he explained it, but he didn't really like go step by step. So I'm going to try to go as step by step as I can through this, to maybe give some clarity to how this is done. It's really not overly complicated. It's just knowing the right stages of kind of working with this stuff. So yeah, that's kind of the effect that we're going to be going for. And we'll talk maybe just a slight bit about Heightfields and kind of conceptually what we're doing there and how that works. And from there, then we'll get into the actual, tweaky stuff and, the weirdness of, kind of what's happening here and why it's working and what it's doing and things like that. Okay. It's kind of some standard disclaimer stuff to start the stream off. First of all, Discord server is at houdinihangout.com. If you want to go there and download these files and follow along, please do that. That'd be great. Make it a little easier for you. And also, if you have questions or thoughts or anything like that throughout this stream, please feel free to drop them in the chat. I am definitely not here to just kind of talk at you. But if you have any questions or if I missed a little something, please feel free to bring it up, ask questions, say, hey, I think you actually did that in a really dumb way, or, hey, you could have done it this way. And I'm always happy to have, constructive criticism, any thoughts or comments, ideas. There's no stupid questions here. So if you think, oh, I missed something really simple here and I don't really know what's going on, ask, because somebody else might have missed the same thing. So there's no dumb questions, and every type of thing is welcome here for you to kind of look, ask questions about and question and that type of thing. So anyways, please feel free to ask questions as we're kind of going through this. So, but other than that, I guess let's dive in, and we'll kind of get started with some Heightfield fun. All right. So what do we got here? So this is my super complicated scene here at object level. We have two things. We have a camera and some geometry. And we can just play it back. If you saw, oh, why is this playing so slowly? There's something selected in here that's dumb. Oh, right. Because I'm calculating at every frame, and that's kind of stupid. All right, that's right. I actually saved this out to another folder. So let's do this. Let me just make sure this is going to the right place. Yep. I'm just going to cache this out real quick. I'll save this out in the background. Let it do its thing. Actually, let me cancel that. So one thing to keep in mind here is that, angry at me, I'm sure. I'm actually going to turn this on, and I think this will be better. Yep. So I'm going to cache this out to disk, and you'll probably want to do the same because it'll obviously be angry at you. So what this is going to do is obviously cache out to disk the Heightfield file, and it actually should have been checked on simulation. I don't know why it wasn't, but it wasn't for some reason. Basically, what simulation means when you have that checked on is that it's going to go one frame at a time. It's not going to try to just do everything kind of simultaneously. If you have a lot of things that can kind of load and save really quickly, not having that simulation checked on will actually allow you to have, like, for example, my computer has 32 cores, so it'll run 16 instances of Houdini in the background. That's a top network PDG type thing, but just know that that's how that works. So anyways, if you're grabbing this file, just make sure you check that on actually, and then it'll run a little bit quicker here. And this should load it from disk, and now we have our simulation here. So let's take a look at this from object level, just so we're not too maybe overwhelmed with what's going on in there. So, and of course, nothing is happening. What in the world? I had this all set up and nothing. Oh, so I have another cache up here. I have more caches. All right, so let's. Oh, does it really? That's interesting. I'm glad you let me know. Let me know if it keeps happening, Apoxia. I appreciate you saying that. All right, I'm going to save these out. There's other caches in here as well that you'll probably want to save out. So I'm going to save that cache. Let it. Is it still taking a hit when I'm doing this, or is it just for that other one? Huh. Interesting. See, I can't actually hear that because it's going through my... So I'm hearing my audio interface. Yeah. See, I hate that. I don't want it to be correctly. Thanks, man. All right. While this is caching, I'm going to just try something real quick. Time out. There we go. Are we back? We good? Hello? Hopefully that sounds a little better. Yeah, so I actually run my my audio through a what do you call it? A little denoiser thing, just to make sure that there's no weird background stuff. That one's a little faster to run. Okay, now we should have that. Let's try this again. Yeah, that one's using most of my that one's using most of my CPU. Hopefully that's okay. Might have to look into that because I definitely don't want that to be happening in the future. All right. Sorry. I forgot that I needed to recache these out. I should have done this before the stream, but that's okay. I moved it to a new location and forgot to update my cache. Hey, Miguel. Nice to have you, Houdini noob. Yeah, I think we're all Houdini noobs. No worries there. All right, let's see where we're going. There we go. We've got geometry. All right, so this is what we're going to be kind of talking about here. This effect. So this was just kind of my take on what they did. I didn't go through the trouble of, smashed my knee. My wife has a keyboard tray underneath the desk, and I smash my knee on it all the time. That sucked. That didn't feel good. Okay, anyways, sorry. So this is kind of my take on the kind of the visual that they had done, and we'll kind of walk through the different parts of this. So the most important thing that's happening here is that this is a height field first and foremost. So if you've never worked with a height field before, let's do this, and I'm going to hop out of the camera so that we're kind of in a better view here. I have my screen dark because it's going to allow us to visualize my background dark to visualize some of the height field stuff. But if you're looking to change that, you can hit D over the viewport. You can go into your background and change the color scheme right here. We could change it to a gray. Actually, that's probably pretty nice. It's a little less intense. So here's our height field. What a height field is by nature is a two-dimensional VDB, or volume, I guess in this case is technically a Houdini volume. And what it is that we're going to be doing is using this volume to kind of store different types of data. So we have two different volumes here. Let me click on a little eye here and bring this up. So we have two different volumes. One's the height and one is the mask. Now, mainly what we're going to be working with is this mask volume, because that is sort of custom made to tweak all of the height field tools and things like that. So most of the time we're going to be messing with this mask value. But our height value, now these are both float volumes, right? They have float values in it, and they're in a grid of 1024 by 1024, right? They're only one high. And so what we're going to do is basically store float values in the mask from 0 to 1, and in the height for whatever height we want. We can go kind of as high or as low as we want. It uses positive and negative values. And so that height is going to be what we actually see. So as we change the values of our height field, that's the kind of visual that we're going to see in the viewport here. But the mask will drive some of these tools as far as layering and doing some different effects and things like that in here. So we're going to mainly work on mask, but we also will have this height, which is going to be what we end up seeing in the very end. So the thing you should know is that you can split these apart. You don't have to have, you can work on just the mask, so you can delete the height and just work on the mask. So they are technically two kind of overlapping volumes, but what you're seeing is mainly the height. So that's kind of the base concept of height field. And so what they were doing I just wanted to clearing these errors out, make sure those are okay. So what they were doing and in this technique is basically adding in a mask to this height field and then advecting it, right? So just to show what, if you type in HF, that'll bring up basically all of the height field nodes, with the exception of, there's one that's should not belong here. What is it? It is hair growth field. That's the only one that's not a height field in that. So HF is a pretty solid starting point if you're working with height fields. Now, what I'm going to do first is just show, I think there's a paint here. Let's see. Height field paint. I think that'll work. Yep. So let's grab this. And so this is a way that we can actually paint on our height fields. And now you can see that this is huge in our scene, right? This is like, why is my brush so big? Well, what I should explain as well is that if you just put in a height field by default, since these are made to sort of be used with terrains and things like that, you can see the size is actually 1 kilometer. So when we zoom back out here, we can see that this is at, 500 on each side. And if we were to wire in this height field paint and check it out, go down here, sorry. Now we can see that this is actually a more reasonably sized brush. And if we come in here and we paint, we're going to be painting on our mask, right? So we're actually adding this into the mask. And so then you can do some fun stuff like if we do HF noise, right? And just do this. Now you can see that we're basically painting noise onto our height field using this paint. And we could come in here and do this some more. We could add in some more areas here and stuff like that. And this is really pretty quick because what we're inherently doing is just working on a fairly small bit of data, right? We're working on a 1024 by 1024, basically image in a way. It's not an image, it's a volume, but you can think of that as like pixels, right? Each voxel is its own now 2-dimensional. We have basically 2-dimensional voxels, even though that's really not a thing. We have a way to kind of store this data pretty simply. And so we have 1 million voxels in this case. So you could almost think of this as like a megapixel, 1 million pixels, right? And if we wanted to change this, we could change the grid spacing, go to 1. And now we're going to have, what is this effectively now on each side? We're going to have 1,000 by 1,000 here on each side, right? So the grid spacing is to 1. And so now we have 1,000 by 1,000 and we get a bit more detail in here. So if we change this to 2 and look at it, you can see it's softer. Change it to 1, it's going to get sharper. If we go to 0.5, it's going to get a bit sharper again, but you might not even see those details. And still we're fairly interactive speeds here and stuff. I mean, it's not crazy. Like if you get really close in, it can kind of actually slow down a bit. But when you're back, it's pretty decent speed. And this is kind of how you might do something like landscapes and things like that, right? So this is the base concept that we're going to be using. So I just want you to have that in your mind and kind of think about it that way. And what we're doing here, just to remind you, is that this has both our height and our mask on it. But when this port is kind of only looking for our mask layer, and this one is kind of only looking for our terrain, like our height. So that's the idea there. You can see here the noise is being added to height, the mask, we're looking for mask, and the combine method and all these different things here. There's a bunch of different things you can do, right? Mess around with the noise, but that's the general idea here. So I'm just going to get rid of that. And you can see our height field is quite a bit smaller. And I was doing this mainly just so I could kind of reverse engineer what they had done in that demo that they did, just so I wasn't having to guess at every single kind of parameter and every different way of doing things. I knew more or less that I could just kind of use this and go from there. So here's kind of the way that they went about this, and you might be able to do this multiple different ways. However, I'm just going to follow what they did and then kind of talk us through that, right? So the first thing that they did here is use a bound node to create the boundary of our geometry. This just makes a box, a very tiny box that will then create our volume for us. And at this point here, we have a volume that's going to be created here. And now this is going to be a little different because this isn't actually going to be a height field. This is just going to be a standard volume that we can work on. And the one thing that's nice about the traditional Houdini volumes is that we can specify that they're two-dimensional, right? And this one here is on the XZ plane. I don't know why this initial value is the way it is. That's fine. We don't need initial values here, I don't think. Oh, maybe. Maybe there was a reason for that. Actually, there was, because it's making sure that those aren't empty, basically. So this is just a really, really low value. This is just 0.000, 4 zeros and a 1, I think, or 5 zeros and a 1, whatever it is. But basically just making sure that these aren't empty voxels so that they don't get kind of culled away if we change it to a VDB or anything like that. Just kind of keeping it more or less, the same shape. So in here, you can see that we have some things set up. We have our uniform sampling division set to 1024. So in this case, our mask is going to be 1024 by 1024. And so here in our height field, we don't have to have it specifically set to this for this volume to be done, to be that resolution, right? To be 1024 by 1024, because we're explicitly stating it here. Now I have this linked to my grid samples up here. So they are going to be linked together, but you don't have to technically have it that one. Hey, Ruben, welcome to the stream. But in this case, it's going to be helpful. So we have our mask, right? We're creating this new mask volume that we're going to work on. We're also going to be creating a velocity volume, and this is going to be a vector. It's going to have the same resolution, same dimensions and all that kind of stuff. And this it's a vector, so I'm initializing values in each of these three X, Y, and Z attributes, basically. And so here we're just doing it in one because this is a float or a scalar as they call it here. Same concept. So at this point right here, we have two volumes that we're going to be working on. And if you go through and watch that presentation, you'll see that they did all of their, or I think all of their stuff in volume wrangles. Now, I actually think that's a really good way of doing this because it kind of simplifies the code a little bit, but I just gave myself the kind of caveat that I'm going to do this with VOPs just so that we can kind of talk about it maybe in a little bit more of a visual, style. So that's my idea here. And we can kind of go through that and talk a little bit about that. And there wasn't anything that I ran into that wasn't kind of a one-to-one with what they were doing. I mean, maybe there was a function that was a little more efficient for, visual, maybe writing it or whatever, but I didn't run into anything that was like inherently an issue. So what we're doing here with this create mask and then this next little section here is we're adding a point. It might be a little hard to see. Let me just bring this up. Geometry, no. There we go. Just make that a bit bigger. There's our point marker. So there's one point in here. And this point is going to drive where our volume gets sourced from. So right here, what you can see is we're sourcing a volume into here. And this is obviously still in that two-dimensional volume, but let's take a look at what we're doing here. We're basically using this point to kind of set an area where we want to source our mask into, right? Because we're going to source and then advect. So let's take a look at this. So this is pretty straightforward. I'm just going to collapse this for now and bring up the parameter pane so we can see this maybe a little bit bigger. So here is our network. Just want to organize this a little better. And what I did was I just did a point cloud find radius. And what this basically is a way to just kind of find a point based on a radius. So it'll give you multiple results. And in this case, we have max points at 10 and things like that. But you could set this to 1. If we set it to 0, it's not going to work. But anything over 1 is going to work just fine. And in this case, I am just going to grab just the first instance of it because that's all that we really need. So the thing to remember here is that we aren't working in a volume VOP. We are not working on the geometry. We're working on the individual voxels in our volumetric grid. And that brings a few things that are different, right? If you look at this, compare this volume VOP global, kind of these incoming attributes, they're a little different than what is traditionally on a geometry VOP, an attribute VOP that does points, primitives, vertexes, things like that. So you get some of the same stuff, time and the inputs and things like that, but you're going to get some different things here, like center, the origin, the size of it in a vector, the resolution in X, Y, and Z. And then you also get this, which is IX, IY, and IZ. And what this means is this is the index of what the actual voxel index is in both X. Now Y, in this case, I think Y, I think this is actually like turned, and it's X and Y that are the two dimensions that we're using. If you look at this, well, actually, no, sorry. In a height field, that's true. I don't know if that's true in a 2D volume, but if you look at this here and we inspect this, we can see that the height field is 1024, 1024, 1, and you can see that Y is facing this way. So this is our XY plane. But now here, I'm not sure that that's totally true. And if we look here, yep, we can see that the mask is actually in the X and the Z, and Y is 1. So it's oriented slightly differently, but they're going to sit in space in the exact same spot. So no harm, no foul. But anyways, so we're finding the point. We're finding what voxels are closest to this point within a radius of 0.25. So if these voxels are 0.25 distance away, we're going to do something with them, right? Those are going to be selected basically. So here, what this is going to say is get the element. So the result is going to be the closest point or whatever, right? And so if the point exists basically, and we have a value of that point, we're going to do a compare here, which is going to check this against -1, right? So if it's -1, it's going to be, if it's equal to -1, it's going to be true. And if it's not equal to -1, it's going to be false. So, and then in this case, we're using input 1 if condition is false. So if it's false, we're using 1. If it's true, we're using 2. So you can see here that we have two different values. So this is our input 1 if condition is false. So this is our false value here. So if we yep. Okay. So basically we're going to be setting it to -1 if it's false, and this really low value if it's true. So if this is -1, we're going to set it to this. If it's not -1, we're going to set it to 1. So basically what this is, and then we're going to bind that into mask. And when you're working with the volume VOP, you can just name the bind attribute is just the name of the volume you want to write to. Now you need to have that, obviously, so we need to have this named mask. So that's something to keep in mind here. This has to be named mask, and this one needs to be named velocity or val. So an important distinction there. So that will bind to that, output that attribute, we're all good. So now from here, we should see that we have that little circle of volumetric, information, right? We have those voxels are basically activated to a value of 1. So we're all set there. And the rest of them are set to a really, really low value. So let's take a look at this and what we're doing with the velocity, right? So we've got our same thing here. We've created this 2-dimensional velocity grid. And what we're going to do is we're going to create some curl noise on this. So this is a little more complicated, but it's not too bad. So what I did here was set up just basically a curl noise value that I'm calculating, and this will define what our velocity is. So so what we're doing here is we're taking our volume input. So we're inputting the position here. We're grabbing the component, here. So this is basically saying we want to set one of our components to 0 exactly, because we don't want to be we basically just want to be looking at the two-dimensional grid. So we want to just zero out our y axis. And similarly, we're going to zero that out as well for our velocity field, because that's going to really affect how our noise, our velocity pushes and advects this mask throughout our height field, basically. So we want to make sure that we have these set so that they're just in the X and Y plane and not trying to push things up in the Y axis. So we just want it in that one plane. So that's the basics of just what's going on up here. Now this looks kind of scary and freaky, right? But this is actually fairly simple. And basically what I'm doing is I'm taking time and bringing that into the offset. However, I'm splitting that out at first and just multiplying it by a few promoted parameters. That's what these little dots mean here, these little kind of extra little tags or whatever you want to say. Those are just promoted parameters. So if we come back up here, we can see these are all the parameters that are on this volume VOP. And you might think, man, that's really annoying. Now, all you have to do is middle click, promote parameter, it'll make a new one. Now for this curl noise, while that is all well and good to go through and middle click, 10 times, what you can also do is right click, go to Vex and VOP options, and there's a thing that says create input bindings or something like that. I think it's not showing because they've all been set, but let me just grab another curl noise here, or just another noise of some sort. Let's just do a turbulent noise, just to do one a little different. If we right click here, you can see it says create input parameters. You can also create input constants. We're going to create input parameters. And what that's going to do is that'll actually promote all of those here. You can see those have all been promoted down here. Now I actually had a separator in there before because I was trying out some different noises and I kind of wanted to keep it separated so I could make sense of it. But this is a really quick way to do that. And I actually only just saw that the other day. So if you didn't know that existed, I had no idea either. So, yeah, it's a nice little trick if you're working with VOPs. Sorry, my microphone just shifted for some reason. Guess it wasn't sitting all the way flat. Okay, so what I'm doing here then is, since we have time and that's going into our offset, basically I just set up a multiplication of the time and put that into this vector. So this is the X scale, the Y scale, and the Z scale. And you can see that right here. The offset speed is just kind of calculated based on those things. So it's going to move a little bit in X, and it's going to move a decent amount in Y. And when we're moving in Y, we're basically just moving through the noise field. We're kind of slicing through it. Since we're in a kind of two-dimensional plane, it's actually moving up and down in Y, but it just kind of looks like it's evolving basically. So that's just going to work out fine. And this is going to just kind of do what it needs to, and it's going to give us this curl field, basically this velocity field that's going to allow us to affect our points. However, if we want to take a look at that, we can use this volume trail to kind of see, inspect a little bit closer what's going on in there. Hey, Fracteller, welcome to the stream. Nice to have you. So what I'm doing is just converting this to a VDB. It actually does become invisible now, which is sort of annoying, honestly. And then we do a vector merge. And the idea behind this is that here we have three velocity volumes or VDBs, and we just want to merge those into one vector VDB. So here it is, velocity, vector 3. If we look up here as well, this is actually 3 separate. You can't actually, well, I think you can have, there's a way to do that, I think. Can't remember. I thought I saw something just recently, but by default, most Houdini volumes are X, Y, and Z, like they're split up like this, which makes them a little bit more dense than a velocity VDB, because those can actually have deactivated voxels, whereas standard Houdini volumes are dense and don't have that ability. So they store a little differently and take up memory a little differently. But anyways, we're eventually going to need this as a VDB for the advection. So I just converted it here. And here we have just a grid that's roughly the size of, or it is the same size as our height field. Then I scattered some points on it. You can do more or less. And then I use this volume trail to kind of visualize this noise. And so what this does is basically starts at all of these points here, at these points there, and then just kind of moves along in time using the velocity values to kind of trace a line through that field. And let's do this. That's kind of a little easier to see. And so as we animate this, you'll see that these are going to change and move, and they're going to kind of take different paths. And this is just the field that we're going to use to kind of push our mask through this, right? So this is our velocity field that we're going to use. And that's just a visualizer there. All right, so everybody following along? Everybody good? Any questions, any thoughts? Let me know. Please, as always, any thoughts, any comments, any questions? Chat is open. Comments are open. Love to be able to clear anything up if I'm not explaining it well. So always happy to kind of make these things as clear as we can, especially since other people might watch them. And if you're if you're questioning, then other people might be. Cool. Glad seems like some people are feeling good. So if you have any questions, let me know. All right, we'll keep moving on. If we see any questions, I'll be happy to kind of go back and address them. So we've got two different solvers in here. And the interesting thing is this is going to be sort of similar to the technique that we used when we did that burning cloth recently. And that's kind of this accumulation idea, right? Where values kind of accumulate over time. Now, in this case, it's going to be slightly different. We're also going to create a timestamp as well, which is like what we did in our burning cloth as well. And so there's some interesting little maybe differences there, but I certainly think it's a pretty cool example of what can be done. Sorry, I just realized my light is way in a weird spot. Give me 1 second. There we go. Okay. Oh, cool. That's what's using to color the lichen. Lichen? I don't know how you say it. Lichen, I think is the right way. Anyways, I can talk well. I can talk good. All right, so let's take a look at this solver here and see what's going on inside. So there's not too much happening here, but we'll kind of go through a little bit at a time. So what we're doing is we've got our inputs up here, right? And we have our previous frame, which is the kind of the secret sauce of doing a SOPs or a solver node in SOPs. So this is kind of what's bringing in the data from the last frame and kind of allowing you to keep working on that. Then this is always going to be the live kind of input 1, and this is the live input 2. And you can see that those are just object merges. There's nothing really fancy going on there. All right, so the first thing we've got here is a switch. And all this is doing is enabling it switching after frame goes past 1. So if frame is greater than 1, or if frame, when frame is greater than 1, it's going to switch the inputs. You can see it's right now going to input 1, so it brings that in for the first frame. And then when we get to the second frame, it's going to switch over to this previous frame, and we're going to work on that the rest of the time. So only for frame 1 will we need this data stream right here. All the rest of the time it'll be coming from our previous frame because we want to work on that previous data. So, okay, so we've got this switch in here. Then we're going to convert it to a VDB because if you remember, we're bringing in a volume, a Houdini volume, and we're going to do a VDB at vect. But there's a couple reasons I started playing around with this a little bit, and I realized that it made more sense to leave it as a Houdini volume when it gets to the end, and then therefore when it comes back in at the start. So instead of converting this one to a VDB out here, I'm just doing it inside of here. And that might incur a little bit of overhead, but I really liked what this volume blur was doing at the end. And this seems to only work on Houdini volumes. So I just went with that. It seemed to work really nicely, gave me the best results. So I just converted back and forth to VDB, and it didn't really seem to give me too much of a overhead on it. So I was kind of like, okay, no big deal. So input 2 is going to be our velocity, right? This is bringing in our velocity field. So here's velocity. This again is mask. This is going to be mask. So this is always just bringing in our current velocity field. So here we've got our VDB that's mask now, and we're going to advect this. So what this is going to do is basically take the mask and advect it by this velocity. And we can do some different things here, like adding how many substeps of advection we're doing and things like that. But I didn't really change too much here. Now in theirs, they had this as a third order Runge Kuda. I don't know the difference between these. I didn't look into these, but you might not need that. You could maybe go back to a second order. I don't know. I just was like, well, they did it that way. I'll just check it on that. Play around, see what it does. You might get different results from that. So this is doing the advection. And then from here, this is the kind of the math part of this. And we have another volume VOP here. So what we're going to do, just based on the name here, is we're going to add the masks together and then set them to a minimum value. So we're basically adding the previous frame to this advected frame. Or sorry, yeah, we're adding the previous frame to the advected frame. So here we're going to take, we're inputting from this first input, we're inputting the mask volume, and then we're also sampling from our second input. We're also going to be taking the mask from that as well. Now this one, I just did it as primitive number and not primitive name, but this, if we set this to mask, would do the exact same thing. Now we only have one primitive coming in here, so they're both going to be the same. So we're going to add those two together. So we're basically adding the previous frame and the current frame together. And then we're just going to set the minimum. So either the minimum is going to be the addition of those together, or one. It's going to look at the two of these, and whichever is the lowest, it's going to set it to that. So it's never going to let it go over 1, right? Because if those two add together to 1.5 and the minimum is 1, that just keeps us within that 0 to 1 range, right? So they can add together and keep kind of going up and up and up until they get to 1, then they get capped there. You could also probably do that with a clamp as well, I guess. It would work relatively the same, but this was the method they used, so I just went with it. But, you know, you can play around. And then that gets exported back to a mask. So this is all pretty straightforward. Then we convert it from a VDB back into a volume. So now we're back to a volume. This here is a VDB that we're working on. The volume VOP works on both VDBs and regular Houdini volumes, just as a note. Here we get the convert VDB, and then we have a volume blur. And so let's just visualize what's going on here, right? So this is what's coming in. We have a value of 1 here in the middle, and then value of 0 or very close to 0 on the outside. So if we take a look at this, we can sort of see what this is doing. Let me just pull this back open here. And let me pin this over on the side so we can use this, and we'll visualize this. So if we adjust this voxel radius, you'll see how this is blurring the edges, right? So this is going to just kind of blur the edges of our volume here. So we only want a very little bit of blurring, because what that's going to actually do is kind of help us grow this field, right? So that blur, as it's kind of pushing out, helps to introduce more growth outwards to this kind of mask. And this is going to be the start of, and really kind of the driving force of what is going on in this simulation here. So as we go through this here, we can actually just visualize this, and that's just fine. I'm going to uncheck that. So we can see that this is going to be kind of this growing simulation that's happening here. And it kind of continues to push outwards and grow and get advected through this field, or through this like kind of two-dimensional volume. And if we look down here, we can get just a better playback speed of how this looks. So there it is right there, kind of in real time, infecting everything. And what I actually did on this solver, oops, don't want to calculate all the way through. I actually added 2 substeps. And what that really will do for a solver is it will, hello, there we go. Just getting an error. What that'll do is really kind of just speed up how quickly it processes it. So for each frame, it's going to do 2 steps more or less. So it's just kind of a way to speed up the infection, the kind of the spread of this. So you don't have to do that, obviously, but you can see here that as it's simulating, you'll see it actually each frame. Actually, I'll just skip it ahead. You can't read it, but down here in my bar, it says basically it's showing half frames basically that it's simulating through. So for each frame, it's actually doing 2 and it's doing 1.5 in between. So anyways, that's what we're getting. So we get this. I just saved it out on whole frames because it didn't really matter. And we get this kind of nice advection simulation going through here. And you might think, oh, wow, we're really close to being done. However, we kind of aren't, because we have this this 0 to 1 kind of growth going on here, right? But the problem is we only really have this very small edge to it right here, right? And what we really want to be able to do is control how the edge of this propagates. That's kind of one of the keys to how this works. So just like we were doing with our burning simulation, we need a way to kind of denote when these values have kind of gone past a certain threshold and kind of where they're initiating, kind of going over some sort of specific threshold, right? So we need that ability to be able to then say, okay, say we want to look from this frame to this frame and have a ramp there, we can kind of set a ramp based on a number of frames and kind of create that from this shape. So the shape is good and is obviously super so this shape is obviously important because this is going to be the shape that kind of drives that, but we want to really specifically work on the edge of that now so that we can have a kind of a fall off that goes across the edge of this. So that's where this next solver is going to come in. All right. So there's really only one other thing we have to set up here. And since we're doing a timestamp, and the way that they kind of did their logic, they wanted to give an upper bound to the to what value is going to be stored in each of these voxels, right? Because remember, we're just storing. Thanks. Yeah, it's getting there. Thanks, Freck Teller. So we're starting to get to a point where we have kind of like a value that we're going to store in each of these voxels. That's going to be our timestamp. So we're going to first set an upper bound to that, right? And use that to kind of allow us to do some logic in this next solver. So here, I'm just using a volume adjust fog, which is just like our attribute adjusts that I like to use because they're relatively simple to understand and have a nice kind of unified user interface. But all I'm doing here is setting mask to a constant value of 240, which is the last frame in our timeline. So that's really all I'm doing here. I'm adjusting the value of this fog and setting it across the board to 240. So now every one of these voxels in here is all set to 240. What I can do to check that kind of quickly is if I do a volume slice here, you saw this inside of the other one. If I do a volume slice here, check out mask, right? Do this on the XZ plane. We've got a mesh here, right? So this is kind of a heavy operation. It's not super light, so it takes a little bit to calculate that. But what you can do then is say visualize, and I think, yep, there we go. Each of our points will actually come in with our attributes, right? So you can see here that we have our density and it's set up to, 240 or for some reason very close to that, which is probably just how RFN is evaluating for some reason. I mean, I think if we delete this channel here and just have it set to 240, for some reason it's not setting at 240. That's really weird. I don't know why it's not setting as specifically that, but anyways, it's close enough. No clue. Anyways, so we have this attribute stored in all of our voxels here. We can see that each point is now one of our voxels, right? So those points are all telling us the values that are stored in there. Anyways, back to this. So we've got our timestamp here. So the first is going to be this just straight up mask volume that has all 240 written across it. And then we're going to do some logic in here. So this is where we're going to create our timestamps. Let's jump in here. And this is actually a pretty simple network. Again, we have our switch if. So if we're on frame 1, we're grabbing input 1, and then everything from there, we're going to go over to our previous frame. And if you look here, you can sort of see that something's happening here. It's a little hard to tell. There's some spreading going on. And the reason for this is that really what we want to visualize here, it's not exact, like we're not exactly visualizing exactly what we want to, because these values are going to go super high. So we're actually, with a volume, really all you can set is almost like a density, right? So once you go past 1, the density is kind of too high to really give you anything meaningful, right? So anyways, so we've got our switch going on here. We're pulling in that information, right? So boom, pulls it in, starts calculating it. And then this VOP is where most of the work is going to be done. And so let me just rename this. Oops. Just going to rename that so it has something a little bit more a little more official there, that someone can actually understand what's going on. Okay, so this is our timestamp logic. So let's jump in here and kind of talk about what's happening. And this is going to be a little tricky to visualize. So maybe what we can do here is, okay, so what I'm going to do is let me do a volume slice again here. Grab this and open up the parameters. We want this to be set to our mask, but for the visualization range, let's do a little different. Let's do 1 to 240, and that should give us what we want. Yep. So, all right, let's talk about what's going on here, and I'll keep this, I think, locked. We'll jump inside of here. Perfect. So what is happening here is that we're bringing in, we're sampling our volume from our second input here. So really the only thing that matters is what's coming in from input 2. We're going to write that onto input 1, right, and read it in each frame, but really the main thing that's happening here is this input 2 is coming in, and this is coming in live, and that's kind of the important thing for us. This volume here that's happening. So that's driving the logic for the most part. And so what we're doing here is we're bringing in a volume from the second input. We're reading that in. We're comparing that, right? And we want to say greater than some specific number. Now this is a promoted parameter. That parameter is right here, and that's a threshold. So once that value goes over 0.005, once it goes over that, this then is going to evaluate as true. So that's important, right? So we want to have that value. We want to basically say, is there a value stored in that voxel? Our baseline is like 0.001 or whatever, so it's super low. So once that threshold goes up over that 0.005, then it's evaluating as true. We're also binding in the mask from the first volume as well. And we're going to compare that here. So if the mask number is greater than the current frame, so if both of those are true, so if the volume sample goes over that threshold and the mask frame number, quote unquote, that we've set is above the current frame, if both of those are true, that is going to trigger this two-way switch. And so what we're doing is if it's true, we're going to use input 1. So that's just the current frame that's going to be written to it. So if both of those are true, it writes the current frame to that voxel. If they're not true, it just writes the current mask, which is 240, right? So the only time that these both will be true is when we haven't written anything into that voxel, and that puts it at over 240, which means the current frame is always going to be higher than this current frame is always going to be higher the mask frame is always going to be higher than the current frame. It's a little bit of mental gymnastics. It'll make sense as you kind of think through it a little bit. If you want to hear them explain it on the stream as well, they talk about it there too. Maybe that hearing both our explanations will make sense. But basically, this is the same as how we're doing that stuff with the burning. It's a little bit of a different logic, but basically once these two things are satisfied, it'll write the current frame in there. And from that point, both of these can never be satisfied anymore because the mask frame will always then be lower than the current frame. So that will kind of invalidate this whole second part of the logic. So once you write something into this volume with the current frame, that's it. It won't write to that voxel anymore. So, and that's writing it back out to the mask there. So that's what's happening. And when we see this volume here, we can see that we're starting to get this kind of weird fade going here, right? So this is starting to do something really interesting for us. We now have the stored value of kind of when all of these are first activated, right? So if we go through now and look at this, I'm going to go up. Oops, sorry. I'm just going to grab this, go up, and I'm going to look at this. Since this is our sort of stored value here, right? So as we move through this, we'll see that that this now has this kind of field to it that I'm just going to smooth shade this so we can see it a little better. Now we can see that there's this kind of continual fall off here of these values towards like the last activated voxel. So if we go further here, this is the very last frame, and they fade right into the red because red is the furthest extent of where that could possibly spread to, right? And if we look back at this at vect, we can see that sure enough, this sort of just lines up exactly with where the boundary of this really faded out kind of red edge is going to be. So this is exactly what we need now. And this will allow us to feather a value between kind of the leading edge of where these values have gone to back a certain number of frames, right? So what we're going to do here is start to create a ramp that does exactly that. And it goes from 0 on the outer edge here, and then it gets to 1 a certain number of frames back. And we can define that using this fade length. So I've made a couple parameters here that will allow us to kind of take a look at how we can control this. However, let's look inside first and kind of talk about what's going on in here. So hopefully everybody's following along. I know that was a little bit maybe mind-bending, but I think if you open it up and really play around with it. Good night. Yeah, continue along. Glad to have you. Thanks, Vecteller. But if you open this up and take a look at it, I think you'll get a good sense of what's going on here. And you can kind of sit with each of these individual pieces of it and kind of break down the logic kind of piece by piece. So I think you'll be able to kind of follow along as you break this down. So we're bringing in our mask here, right? And we're going to compare it to if it's equal to 240, basically, right? So if it's equal to 240, we're just going to use input 1 if that's true. So we're going to set that equal to 0, right? So that's pretty easy, right? We don't have to worry too much about this. This is basically just saying everything that's outside of this, because now we have this mask value that's setting that there's values from 1 to 240. So if this is equal to 240, we know it should be to 0. So that's fine. That's all the stuff that's out on the edge here. So just set that to 0. If it's not, we're going to go down through this logic down here. So here's what we're going to do. We're going to take the mask and we're going to subtract that from the current frame number. So let's just say the mask is let me think. So if the mask value is 12 and the current frame number is 6, that's going to set that number to 0.5, right? So it's going to be a half. So we're going to basically be using the mask and the current frame to drive some of these, to basically create this ramp. And let me just look at this here exactly. So this is our fade length. And so once we take this value here, we're going to divide that by the fade length here. And then we're going to fit that value, and fit and clamp 0 to 1 and 0 to 1. So basically this is going to be making the fade length fit a ramp from 0 to 1 in that duration, right? So this math right here allows us to take the leading edge, set that to 0, go back 30 frames, set that to 1. So that's what's creating this ramp right here that you're seeing. And then we're just having a ramp to kind of control what's going on in here. So that's all that's going on in that range, right? So we're able to kind of take that and set a fall off from that leading edge. And that's going to be what helps us to actually do this reveal effect and have some control over it. So if we look at this now and do the volume slice, now that's actually not even going to work. Actually, sorry, let me go back here and make another one because we can actually look at this a little differently. So let's go down here and let's set this between 0 and 1. And there now we can see that these values have all been remapped, right? So we have 1 in here and 0 out here. And that's from what we were setting, right? And then that ramp kind of controls everything in between. So this is great and good and everything, but we do want to smooth it out. So we're going to smooth that mask a little bit. And that's just going to make sure that these edges are kind of nice, smooth. We've got what we want going on there. You could maybe push the voxel radius a little bit more. You could do that, or you could, could also give it a couple more passes here. And this is just kind of compounding that blur kind of on top of itself. So you can see here as well. Do we have some stuck geometry? Sure do. All right, let's just reset the viewport there. That was weird. All right, so I think it just wasn't updating. So here we go. We can kind of see that we can blur this more or less using these passes. That's kind of the more aggressive way. And the voxel radius is going to be a little, voxel radius is even more aggressive. I was thinking that this number of passes would be more aggressive. My mistake. So anyways, volume blur, we have this as a volume, Houdini volume. So this one will work as well. And so that just smooths out the mask. Then we come down here, and this is a really pretty basic thing. We actually don't even need this. So what we're going to do here is we're going to sample in the second input and set mask equal to that. And if we look at this as a volume VOP, but this is actually working on our height field data that's coming in. You can see we have height and mask. So if we follow this all the way back up, this is our original height field that we were working on. So this is going to come in here, and we can then, use this sample, the sampled value from input 2, to then write that over top of our height field. So now we have our height field and we have our mask set into it. And by default, you're going to get your mask displaying as this red value. And I'll show you how to get rid of that if you want to. You can use this height field visualize, and we'll get to that at the bottom here. However, we'll talk about kind of where we go from there. But so at this point, we've now taken all of that advection, all of that kind of stuff, and we're back over into the height field world. And we're going to just kind of keep rolling from there. So if you guys have any thoughts or questions about this, hopefully this is all starting to the pieces are starting to kind of fall into place on how you do this. Basically, we just did a bunch of volumetric stuff, and we're going to just merge that into our height field, workflow and go from there. So now everything we're going to use from here on out is going to be pure height field setups and stuff like that. So hopefully that'll all make sense and will be good for you. They did have one other thing in this VOP, and basically what that was another ramp to be able to control how this fall off is coming from over here. But I just had the ramp over here, and I was like, I don't really need to implement it twice. They even said it kind of wasn't super necessary for their workflow even. So it was kind of just there for extra whatever. So cool. All right. So now we're into the Heightfield world and we can kind of talk about these tools. I'm going to pull this back over, hide this. All right, cool. So I'm just resampling this here. You can kind of do this however. In my case, what I did was I changed the resolution to like 0.5, and that can just kind of speed it up just a little bit if you want to. Maybe if your computer's running a little slow with it, just might be nice to kind of lower the resolution, work on your height fields, and then if you need to bump it back up, you can. So in fact, you could actually go further with it if you wanted to. So now what I'm doing here is I'm starting to use some height field patterns, and let's look at this. So, oh, sorry, I can just do HF pattern. And let's kind of just look at what this does, because this has a bunch of settings set on it, but let's take a look at this separately. So what you're going to notice is that you're like, oh, shoot, it's gone. No, it's not gone. It's way up here. And this might seem absolutely insane to you. Like, why did it go all the way up there? Well, the reason is that a lot of times what happens is your height field is actually pretty tall because maybe you're doing mountains or something like that. You want a pattern on it. You don't want it to be like this tall when you're working on a kilometer, but we're working at a smaller scale. So you don't want that. So let's set this back to 1, go back in here. And let's take a look at what we want to do here. So let's maybe add in a pattern, and we can reduce the size of this, and you'll start to see, hey, look at that. We're starting to get some sort of pattern. I mean, stars are cool and all, but I don't think that's going to do it. So what I did was instead did steps. No, I did stripes. That's what I did. So this is set to stripes. And what I did is I rotated them. So I just rotated them 45 degrees, right? So we get a little sideways action here. And, you know, you can change the size of them. So this will bring them closer together, right? We probably don't need them quite to be that high. Maybe 0.25. What did I have this at? 0.15. Okay, cool. So we can just kind of keep playing around with the size and scale of everything here. The stripe width here, you know, you can obviously play around with this. And what you can do too is, oops, you can add this post blur in a little bit, and that's just going to kind of smooth this out if you want to. So you can kind of add in this post blur like so, right? So you can also set other things like you'd up the base height and all that kind of stuff. So anyways, this is kind of how I started to do the patterning for that. And so I have this set to add. What I could just do is say replace instead, whatever, just about the same. But if I wanted to, then I could take this down here, add it in again, set this to maximum, right? Then if I turn this to -45, I've got this pattern, right? So now we're starting to get somewhere. We've got sort of some interesting patterning going on. And let's take a look at, oops, actually don't need this, I don't think. Well, we can kind of talk about what this does, right? So we've got these patterns going, right? So we can do all sorts of different things here, but let's talk a little bit about what this mask is going to do for us. So instead of maybe going to all those extremes, let's just take this noise and kind of go from here first. So we've got our height field noise set up. And I'm just going to cut this. And so here's our noise, right? So there's some noise on this height field. What I want to do is drive this by the mask. So kind of counterintuitively maybe to what you would expect from Houdini, you can actually wire this one in just right here. And now this is going to look at that same input for both the height and for the mask. So now we're going to start with nothing, right? It's just nothing. And as that mask animates, we're going to have this start to grow in, right? So we're going to have this height noise start to grow in. You can also center the noise, which is kind of interesting as well, if I can actually get that to work. So like it'll go up and down. So you can see here it's going to kind of grow from there and just kind of infect it as so. But up, maybe is better. I don't know. Again, you can play with this. You can do whatever you want with it. I actually have an idea for kind of pushing this a little further in a second. But so there is our kind of infection. Oh, and that part, I actually didn't talk about that leading edge, but that is controlled by this ramp here, right? So the fade length is right here, 30. So if we up this, it's going to fade in longer. If we reduce this, it's going to fade towards the edge a bit more. So this is our kind of control for that leading edge ramp. And then this ramp right here is just basically controlling these little like ripply lines. And what I'm going to do, oh, the PDG is just in the file cache node. I didn't set that up. I just said save to disk in background. That's all. If you click save to disk in background, it runs a PDG network inside of here. If you go inside, there's a top network in there. That's just the regular file cache. I love that. That's like one of my favorite features that was added recently. So anyways, that's how that's being driven. So if we come over to this noise here, that's just going to be driving the noise straight from this mask here, right? So we have our, again, just to remember, we have height and mask coming in there. So that's cool. But what if we wanted to noise up that mask, right? Well, we can do something like this here. We can take this Heightfield mask noise, which is the, So this is, if you do HF mask, you've got these Heightfield mask, and you can do Heightfield mask noise. Now, really the only difference between Heightfield noise and Heightfield mask noise is just that the noise layer is set to mask and the mask layer is set to mask. So it's noising up the mask layer, basically, based on a mask. So this is adding noise into that mask. So if we do the amplitude here, you can see that we're just adding in some noise here. And I'm setting this to maximum, so it's just basically breaking up that edge a little bit. And if we look here, oh geez, that's obviously not what we want. What did I do? I did something stupid. Oh, right. The amplitude is actually affecting it. So the amplitude is actually causing it to kind of freak out a little bit there. Sorry. But yeah, so this is going to add the noise in there. I was just trying to make it more apparent, but it's there. Trust me. So anyways, this now has some noise on that kind of leading edge here. So that's cool, but this really isn't what we want to do in the end. We'd really prefer it to be something like this, where we take this pattern or a pattern like this and do something with that, right? So what I'm going to do is I'm just going to, maybe I'll just pull this over here, and I'm just going to put some nulls down here just to kind of explain a little bit better what's going on in here. So this is going to be noised mask. This is going to be just our Heightfield by itself. And then this in the middle is going to be a pattern, basically. We'll get to that in a second, and I'll talk a little bit about what I did there. But let's now just take this pattern here and add this noised mask into it. So the interesting thing, there's two different ways that you could go about doing this. You can do a Heightfield layer, or what they did in the video was use this Heightfield blur. And I actually didn't really understand why this was working, but I think I sort of get it. But let's first look at Heightfield layer, because that's kind of nice. So let's look at Heightfield layer, and this is basically a way to blend two different terrains together. So here's your base terrain right there. This is the terrain we want to layer, which is right there. Then the last one is for a mask. So we're going to grab our noise mask, drop that in there. And so now this is going to do it's going to make a waffle for us, right? So we're going to start here, and we're going to start kind of pressing this waffle into our simulation, right? Or into our height field. So that's kind of cool. It's doing its thing, spreading throughout, right? It's kind of interesting. So runs pretty quickly. It's running at about 15 frames a second. It's doing all these calculations and stuff for us. So it's running fairly quickly. And then once you cache this out, it runs super fast. It's really pretty light to cache it out. So that's good. We're getting somewhere. Let's talk a little bit about what is actually going on in this node, though. So obviously we're using our mask. We've got a mask strength of 1. We could adjust that, and that's going to adjust our strength. Could also invert the mask, so it would eat away at this, right? So we could have it eat away at that. And don't worry about the color. That is very easily taken away with this Heightfield visualize set to remove the tinting and remove the material. So there you go. So it's removed and now it just kind of erodes away, right? So that's cool. And that's with this inverted. You can also do some remapping, like scaling this layer. So this would scale the inside layer, or you could scale the base layer, right? Which really isn't going to do anything because it's at 0. Or you could scale the whole thing. So again, those aren't going to be super different because they're all sort of from the same thing. And you could always add in something like a layer blur here to be able to just kind of smooth this out if you wanted to. So that could be really a nice thing to add into this if you want to smooth out some little jagged edges or whatever. So anyways, that is kind of the concept that we're doing over here as well. So let's just, I'm just going to pull this off. I'm going to save this out, but I'm just going to put a network box around this and just say simple waffle pattern. If you want to play with this, you can. So I did sort of the same thing, but this pattern here, I kind of went a little further with it. So here is this Heightfield pattern. And what I did is I added a distortion to it. What you can see here is that as you adjust this distortion, it pushes around this thing, and you can get real crazy with it, but you can kind of push it into these really interesting shapes. So I just kind of started playing around with that a little bit. I had one that was set to 45 and one that is set at -45. Now this is just a reference copy here. So everything is the same, except I just deleted the rotate from it and just rotated it to -45. So this is actually two of those Heightfield patterns just kind of X'd across each other. And then I added some Heightfield noise into this in a multiply and basically just allowed to kind of push some of these sections up just to give some variation so it didn't feel so equal across the whole thing. And then this basically is going to do the exact same thing we just saw. However, it's on that visualization that you, or this kind of thing that you saw at the beginning with the camera and stuff like that. So this is sort of the start of that. Now, also I added a little blur in there just to soften it up a little bit, just so it wasn't so sharp in some of these, mountainy areas here. So that's good. Now let's look at this other side here. I'm just going to hide this for a second. So what we've got going on this other side, we've got this noise mask, and we also have, I think I might have that at 1. Anyways, we have this Heightfield blur. And so this was kind of interesting. And this was how they had done it on their stream was with the Heightfield blur. And so by default, what this blur does is it literally just kind of blurs away these details. And while it's not quite the same as the other option, it does work really well and doesn't take a ton of blurring to kind of blur this away into nothingness. So I'm a little surprised that this works this way. There's some part of me that's like, I don't quite get the math that's going on that's making this disappear, but it's working. And so then if you throw something in like a mask invert, this Heightfield mask invert, which is, Heightfield mask invert, which is just a volume combine node set with a bunch of special things here, complement and clamp 0 to 1. I didn't set any of this stuff. I literally just got it by default, which basically is just taking the mask and inverting it. And so now we're getting this look right here. And so as we go back to the beginning, we've got nothing. Then as it kind of comes in, we get it kind of infecting out and doing its thing. Now there's certainly a lot. Whoa, that was a weird tumble. I must have hit another button. Maybe I hit shift or something. So you could obviously do stuff where this actually could be animating or something underneath. So it almost looked like some sort of like weird kind of fungus or something. I don't know. You could do a bunch of stuff with it, but this was just kind of my starting point to get to a spot where we were where stuff was making sense. Now, what I would like to do, and that's really what I showed online and what we looked at, earlier. So this is, oh, is this actually, oh yeah, this is actually the Heightfield layer version, I think. No? I don't know. This is what's cached. I don't know what the setting was, but it's cached. So anyways. Yeah, if you look at the original one, that's the setting there. So let me just see. Did I screw something up here? Was this supposed to be at 2? Nope, that's not it. What did I do? What did I do? Well, if you look at the start one, it'll be set like this. I don't remember the exact parameters, but anyways, here we are. This will be available as the end version, the one that I worked on. So the worst version, apparently. But so the other thing I was thinking of, and after I kind of put this together, was could you do something where it would almost be like a ripple kind of going through, not like these little these little ripples here, but almost like it goes down and then back up, like it overshoots and comes in. So I kind of want to play with that and see if that can be done. So I'm going to take this stream right here and we'll just kind of, I'm just going to delete this guy. And that's pretty much where we were. Cool. So what I want to do is make a copy of this. I'm just going to bring this down here. Or actually, sorry, no. I'm not going to do that. We don't need these guys anymore. Those are just for visualization. Let's just add a switch here. Cool. And then we can output that there. Perfect. All right, so I'm going to change the way that this looks and see if I can do this. I don't know. All right, let's set this back to linear. Cool. Okay, we've got a linear thing. Now, what I was thinking was, what if I did blast? Nope, there we go. It does work. Okay. I don't know if this will work, but I'm going to try it. Okay. So you can actually go into negative values here. I don't know if this is going to work or not, but we're going to try. Okay. So we have our Heightfield resample. And what I'm going to do is just simply, well, all these things should be the same now, except that. Sorry, just trying to think about what I'm doing here. So what I'm going to do is just make a height field that is just taller. You'll see how this works in a second. I'm just going to switch this in here. And this we're just going to, go up by 0.5. So basically this is just transforming this height field up a little bit. In fact, we don't even need to go that high. We'll go 0.25. So now it's simply going, hey, okay. Yep, it is working. Cool. Interesting. So now what this is going to do is start like that. It's going to go down and then up. Hey, cool. Okay. We've got some noise in there as well. Now that noise is acting a little funny because I think I have that set to maximum. What if I do multiply? No. I always am so bad with this noising up thing like this. I don't know what mode this needs to be in. Sorry. Multiply, blend. Oh, anyways, I kind of don't want that. I just want it to look sort of like this. So let's see. Yep, and that's just linear. So what we can do now is we can play around with this, and I'm just going to shift click all of these like so, and change them to B-spline. Let's see. Oops. That's kind of interesting. Let's change the fade length a little longer here. Yeah. Yep. That's kind of cool. All right. All right. All right. So what if we did something like this? We could actually do a couple of these. I'm just playing around now. That's kind of working. Kind of doing some cool stuff there. All right, so instead of this, let's take this out and we'll wire this in back again. And so now, let's see what that looks like. All right, I'm actually going to shorten that because it actually is too long now. So let's go back to 30. Oh. Oh, interesting. That doesn't seem to work with this version. Oh, because it's clamping. Interesting. Yep. So that wouldn't work with this, but it will work with this method, with the layering method. So interesting. Anyways. So I'm going to push this even a little further. Maybe we'll do this -1. Yeah. Kind of interesting. Just going to set this to version 2. Save this out. Cool. Well, I hope everybody is at least enjoying this to some extent, is getting something out of it. I sure found it interesting to kind of play around with something like this, and be able to kind of understand what was going on with these different kind of concepts in Heightfields. So I think it's kind of cool. It's sort of a different different type of a thing going on here, but this will actually play back in real time now, so that's kind of cool. Yeah. So there we go. We've got kind of some interesting effects that you can do. Certainly you could do a whole number of different effects and concepts with this. You could use it to, have things grow or infect, or, you could have this kind of moving base Heightfield pattern and then have these, have this growth kind of happen within this moving simulation, stuff like that. So lots of different stuff that could certainly be done here. In fact, if you did, if you just did this $T just on one of these, and we visualize that, we'll see that this is going to start to grow and move and do some weird stuff. Let's do like that. We'll slow it down a little more. It's really jerking along there. Look at that. That looks funny. Huh. I see. I know what it is. It's because, I bet you it's because it can't, because they're integer values for the Heightfield pattern. Let me see here. What if I did, instead of this, what if I did the phase? What will that do? Yeah, that should work. Let's do this. $T times 0.25. Let's see if that works. It still is doing it. Well, anyways, we could just do $T. See if that gets us anywhere interesting. I mean, it's something. It's definitely weird. And this is actually only one of the patterns moving against each other. So this is just in the one axis that the pattern's moving. So you could kind of change around the look pretty considerably depending on how you might, do this. But I'm just going to put that back to where it was. So yeah, that is, sort of where I think we'll end this for the evening. Been doing a lot of talking this week, so my throat needs a little bit of a break, but if you guys have any thoughts or questions or anything like that, I'd love to answer them and kind of tackle those before we sign off for the evening. But symbiote vibes, yeah, for sure. It's we got some Spider-Man stuff going on here. Yeah, I don't know if anybody has any thoughts or questions or anything like that. Based on what we've been doing tonight here, but these files will be available through the Discord, and you can go in and grab those and kind of take a look at them, see how this works, and then see how you might want to use those in your work. And if you wanted to copy these Heightfields, say, to a geometry, what I would do is basically take this this Heightfield and kind of treat it as if it's a texture, right? And look up into this Heightfield to grab the height value based on kind of putting this into a 0 to 1 space, right? So basically match the size of this to the 0 to 1 space that a UV map would live within. And then reference from the UV map, maybe make a, do some sort of a SDF and maybe basically bulge out an STF based on the height that you're getting here. Maybe what's the word? Dilate the STF based on the height that you're getting from this Heightfield, and then you could dilate out from there. So there's some stuff that you could kind of take this and move this to the next level. I certainly haven't looked into that side of it, but I think that would be the next logical step in how you would kind of go about kind of taking this and putting it on geometry or whatever, going to kind of some of those next steps. And, any number of different techniques you might be able to do that with. There might even be, there probably is not a node that would particularly look that up, but I think what you would do is do something like, use some sort of a volume VOP again to kind of grab these attributes and move them over. So, but that would be kind of my logical next step. I'm not exactly sure of the details of that, but I think if you're interested, that might give you kind of a starting point to be able to go and look kind of into that in the future. So yeah, I think if nobody has any other thoughts or questions, I think that's where we'll end the stream for this evening. So thank you guys very much for joining us this evening. Coming up next Monday will be another MOPS Monday. So if you have any thoughts or questions or anything like that you want to kind of explore in MOPS, please put them in the Discord. Always kind of keeping an eye on that and seeing what people are interested in learning. I mean, ultimately, this stream is not for me. It's for everybody watching and for people that, want to learn things. So if you have anything that you're interested in, please put it in the Discord, and I will, do my best to get to those in sort of a timely fashion as we work through the different MOPS tools. And one thing that I can say for sure that I'd like to get to, and I'm not sure if we'll get to it this week, but I think maybe, is using the MOPS plus tools in DOPS in the dynamics context, because I think that's going to be a really powerful way to be able to kind of, yeah, you're welcome, Matt. Thanks for joining, and I hope you got a little something out of it. But yeah, so that's kind of my idea for where the MOPS stream might go next. But hey, if you guys have any thoughts on that, please feel free to drop them in the Discord. Yeah, no problem, KG. Glad to kind of give you a little introduction to it. This is pretty complicated Heightfield stuff. I mean, the beautiful thing about Heightfields is that if you just take a Heightfield, do some HF noise on it, like so, you start to get terrains and things like that pretty easily, right? So you go in here and you start messing around with stuff, and then you do an HF erode on it. Give it a second because it's cooking. Doing a little quasi-static sim. Oh. It actually might be simming to... Okay, I'm just going to freeze it at frame. And there you go. You get a little erosion from there. But if we undo freeze at frame and watch this, we'll reset the simulation and let it go. You'll see it kind of erodes and does its thing. Oh, shoot. Thank you. Oh, boy. I'm such a dummy. So yeah, so Heightfield noise, make mountains, make something, right? Grab a Heightfield erode, and then this is just like a little simulation that you can run on it, right? And it'll make, water go around and stuff like that, and kind of create some terrain for you, right? So it does some cool stuff. So yeah, Heightfields are interesting. You can certainly get a lot of really interesting results from it. I mean, that's just from 3 nodes right there: Heightfield noise, and then an erode. There's a couple different erodes as well. There's hydro, precipitation, thermal. There's a few different things like that. So anyways, there's a lot to get into with Heightfields. So certainly an interesting little topic to to dive into. So yeah, hopefully that makes sense now that I'm actually showing my screen. But all right, there we are. There we have it. If you guys would like to join the Discord, please feel free to do so at HoudiniHangout.com. There's an invite link there. And yeah, that is where we will end the stream. Thanks so much for everybody joining this evening and for anybody that might be watching in the future. Yeah. Next thing to note is that the Mops Mondays, I'm doing those at 6 p.m. just to try to give everybody as much of an option as possible to be at these things. And I'm really thinking I might change over my Wednesday stream to be a bit earlier. So if anybody has any objection to that, let me know in the Discord. But I'm kind of thinking that 6 p.m. time might be the sweet spot for me because it gives me a short little window to be able to be done with work and then get into this. So we'll see. Anyways, that's the stream for this evening. Thank you guys so much for joining, and I will see you next time. Bye, everybody.